We want to finish about inheritance, especially we went through the basics about polymorphism and dynamic binding last time. I want to review that very quickly, and then we apply that to two different contexts. One, when you put feature arguments. Number two, you put return values for the feature. Okay, so these are something that's also interesting to see, and we'll use them when we talk about design patterns. Okay, let's do a very quick. So when you look at the last page for the inheritance lecture notes, I have a summarizing table there telling you what you should really check whenever you got polymorphism. Okay, what we learned from last time, we actually learned about two type checking rules. So these are the rules that actually either compiler or the Eclipse compiler actually implement in order to check to see if your code should compile or not. Okay, let's study them very quickly. Okay, so when you see the table in the lecture notes, you wouldn't get lost. Basically, the idea is very easy. Whenever you got X and Y in assignments, right? Also applies to Java as well. So if I want this particular assignment to compile, what would be the rule? Anybody can tell me? Based on what you learned last time on Monday. Go ahead. X is ancestor of Y. Okay, sure. But you want to say the static type for X is the ancestor of the static type of Y. Okay, good. Okay, let me write it down very quickly. Basically, whenever you see something like this, you have to look up what's the static type for Y, and also what is the static type for X. You want to make sure the static type of Y is a descendant. I'll just say it the other way. Okay, it's a descendant of the static type of X. Okay. For the substitutability, right? You want to make sure, because we know that if it is the case, static type of X is ancestor of the static type of Y. If that's the case, guarantee what's being accumulated for Y is guaranteed to be as least many as what's in X, right? That's what we talk about. So it can be substitutable. Okay, let's do a very quick check. Okay, so now, whenever you have this particular assignment here, you want to check to see which inheritance hierarchy you're talking about. In this case, we're talking about students over here. Okay, students, and also we have resident students, we have non-resident students, right? Okay, let's do a few checks. Okay, what about this guy here? Number one, should it compile? Okay, because you know that S2, the static type is RS, and for S1, the static type is S, right? And RS is indeed a descendant class of S. Okay? Are we okay with this? Okay, why don't we do one that is not going to compile? How about this one here? No, right? Because the static type for S1 is students, right? The static type for S3 is NRS. And we know that it is not the case that students is a descendant class of NRS, right? It's the opposite, okay? Okay, guys, how about this one here? Just curious. Should it compile? In fact, nothing to do with inheritance. S is not declared, right? Okay, nothing to do with inheritance here, okay? So, wow. Hopefully you can see that, right? Well, I just hope you wouldn't make mistakes like that on Friday. That's my hope, right? Okay, not declared, right? Good. Now, number two, which about caste. Basically, whenever you want to judge to see whether a particular caste is suitable or not, you want to see either you're doing an upward casting to some of the ancestor classes, or you're doing a downward casting to one of the descendant classes. If it's neither, that means your caste is not appropriate. Okay? So let's have a quick look. Basically, whenever you're, okay, now can anybody try to be formal to me? You want to try again? Now, if I'm given this particular shape of the syntax, which means I'm trying to cast Y, presumably defined previously, and also into class C, what will be the type checking rule over here? Can you formulate it? For type checking, yes. If I give you this particular fragment of code, how do you know if that should compile or not? Anybody want to try? Let's say we can assume Y is declared, and also C is a declared class. That's something we can assume.
Okay, so it will
some kind of ancestor. Well, can that just be ancestor? If you say, well, basically, again, you missed the static type, right? Up or down, right? Okay, good. Okay, that's getting there. Yeah, but to be type correct, you can either go to up or down, right? Okay. You want to say the static type of Y is, okay, you know what? Let me say this. Let me just put it in this way so that's easier for you to follow. You can say C is either ancestor of the static type of Y, or it's a descendants of the static type of Y. Okay, so now in this case we are doing an upward casting. And in this case we are doing a downward casting. Okay, either upward or downward is okay, right? Remember, if you do upward casting, you are basically narrowing the expectation. If you're doing downward casting, you are widening. But you want to make sure it's not too wide, such that it's actually below the dynamic type, right? That's what we said last time. Good. Let's just do quick exercise. Okay, very quick. Okay. So now let's say we got something like this. What I want to do is let's have a look at how about this one here? Do you think this should compile? This one here. Okay, why is that? Okay, RS is a descendant of the static type of S1. I agree. In this case, are we doing downward or upward casting? Downward, right? Okay, from students into resident students. Are we okay? Mm-hmm. Can you, how about this one here? Is it appropriate? Oh, SMS. Oh, by the way, SMS. That's something we'll introduce today. Think about SMS is simply a student management system class, which is not part of the inheritance hierarchy. So we still have only this hierarchy over here. You can think about SMS is simply independent class. Let's say. You won't, right? Very good. I forgot to give you the context. Very good. That's fair. So now basically, you want to say the static type, which is students. You can see SMS is neither ancestor nor descendants. Okay, so that's why it doesn't compile. Okay, you can see the rest by itself. We'll get to a little bit more complicated issue when we talk about feature argument and return value. Okay, I think that's something that becomes worth talking about. So you feel absolutely comfortable when we talk about design patterns. Okay, so now let's talk. Oh, this one. Okay, one more. Sorry, one more. Let's say we do the cast. Okay. You can see that over here, we are trying to do the cast, as I said before from the previous slides. For this particular cast to be appropriate, we know that C is either ancestor or descendants of the static type of Y. That's what we said previously. Okay? So now, I introduce a variable over here. So now, if I say temp, let's say the cast succeeds, let's say. What would be the static type for temp? Would be C, right? Okay. The static type of temp would just be C. Okay, so now for this assignment to be compilable, what would be the constraint? Exactly. So this is more like a combination of the two previous slides, right? Okay, you can see basically first of all you want to make sure this particular cast is okay. If it is okay, we're going to create this new variable pointing to the same objects with a different static type. In that case, you want to make sure the static type for X versus the static type of temp. What's the static type for temp? C. You want to make sure C is a descendant of the static type of X. Okay, it makes sense, right? If you understand the previous two, so this is just like a combination. Okay, let's have a quick look. Okay. Yes, but I tell you what, you can always upcast all the way to any, and then downcast to any class you like. But you don't want to do that. That's actually not very useful to you, right? You can definitely treat the compiler in that way. Yeah. You know what? For this one here, it's actually going to use some return value over here. We can review this a little bit later, so I can get to the new topic quickly. So this is. Let's have a look at what's going on here. Basically, we're trying to do a cast, But now we're casting something that's more sophisticated, which is absolutely fine for your projects. I'm trying to call get S, which means get students, from SMS, which is student management system. Get some value from there, and I want to cast the return value to RS. And then reassign that to some temporary variable, and then do assignment here. That's basically what the code fragment is saying. But we want to know precisely whether that should compile or not. But we'll get there, don't worry. We haven't talked about return value yet, so it's not fair for you to answer just yet. Okay? We'll revisit this if I remember. But if I forget, please review the slides. Okay? I'll try to remember. Well, you gotta remind me. I'll try. Okay, so now I would like to talk about, first of all, feature call arguments. Basically, everything we learned about the polymorphism, about the assignments type checking rule applies over here. There's only a slight extension we need to understand, only a slight one. Now, let's have a look at this one. This really, really important line to see. Remember, when we talk about without the inheritance, we actually got two classes, right? We got resident students, we got non-resident students. They are independent of each other. There's no inheritance there. So that means to create a student management system, we need an array of resident students, we need an array of non-resident students, two separate arrays. But now we have inheritance. We can simply create something like this. We simply get an array of students, and the student is the top class in the hierarchy, right? So now this is something called polymorphic array or polymorphic collection, which we'll see for every design pattern we're going to talk about. Yes? Good question. You're basically asking if you can, if I know certainly that the current element I'm looking at is actually a resident student, can I cast that into resident student? Yes, you can. Yes, but we'll get there. Okay. Okay, I want to just bring your attention to this fragment of code over here. Okay. Let's go over that quickly. Okay, so now what I want to say quickly is, let's talk about student management system here. Okay, that's a class we talk about. And then we have SS standing for students. It's simply an array of students. And don't forget, we got students at the top. And also we got resident students. And also we got non-resident students. So now the number one thing you have to remember as a principle. Whenever I declare an array of students, that means every element in the array has the static type students. Every element, okay? More precisely, when I talk about, for example, SS at position 0, SS at position 1, and all the way to SS, you know what? Let's follow the Eiffel convention. So SS1, SS all the way to SS.count, let's say. Okay? Every one of them has the static type students. Okay? That's very precise, right? It's as if we declare so many variables statically. It's as if. Okay? That's the only extension you have to know in order to understand the example over here. Okay? So now let's see. Now let's have a look at quickly for this particular feature here is a command. So now we are saying that we are trying to add S, add RS, and add NRS. Now what's different for these three features is the argument type. For add S, the argument type is simply students. And for here is simply resident students. And over here is non-resident students. Each one of them, when you declare a feature parameter or arguments, you're declaring its type statically, right? So now, I want you to tell me, for example, do you think this line over here in blue is going to compile? Good, okay, I agree, but why? In this case, they're the same type. You know, to be more, a little bit more formal, you want to say the static type for the right-hand side S. Okay, good. Basically, what you want to say is the static type for S, we know that it's simply just students, which was declared over here. On the other hand, the static type for SS at position 0, as I said before, each one of them will just be you know, the students, right? Is declared over here. So that's why this will compile. Okay. Similarly, if I do this guy over here, can I just do one more? Do you think this will be okay? So this is very critical. The one I highlight in pink over here. Okay, maybe what I should do is, let me just do it a more colorful way. How about this line here? Should it compile? I'm glad to hear some note, so that means there's a little bit of confusion here. That's okay, you know, it's absolutely fine. Should it compile? If you think yes, give me a reason. Same as first line, okay? What is that? Okay, how about the right-hand side? Okay, the static type of RS is declared where? Parameter, I like that. That's simply resident students. On the other hand, let me use another color here. The static type for SS0 is declared where? In the array. Okay, so that means the static type for SS0 over here is also student, right? So resident students is a descending class of students. So that's why it compiles. Are we okay? This might be something you haven't seen in Java, I guess. Maybe not in that deep, I guess. Okay, are we okay with this? Are you comfortable? Let's now talk. Okay, that's basically using the let me recap very quickly, and then we'll do new exercise. Two things to watch. Number one, whenever you define some collection type, whatever class you put in here will be the static type for every element in the collection. Okay, and then whenever you got any feature over here, it doesn't have to be command; it can be query as well. Whenever you declare some parameter over here, the type is a static type as well for the parameter. Okay, good. So now I do have a question for you. Okay, let's try. Okay, so now let's think about, without telling you how to judge systematically, let me just ask you for your intuition. Okay, let's say we got S1. Let me just highlight directly. Let's say we got SMS, student management system over here, which we define add S, add RS, add NRS. Okay, and then we create an empty one. And then I want to focus on, let's say, RS, which is over here. Let's look at this line here. So I got RS, which was declared over here. And then I'm creating this particular dynamic type for that. Okay, so these are the variables we pay attention to. Now, I want you to tell me whether or not this line over here should compile or not. This line. SMS is a student management system. And then we are calling this particular add S feature, which was declared over here. Okay? And then RS was declared over here. You got all the information you need. Should it compile? Let me give you a little bit hints over here in case you have doubts. Call by value. Does it sound familiar to you? Back in 2030? What does call by value mean? You want to look at, well, in this case, because RS is a reference type.
So we'll get a string.
Not really a string. Okay, this is really important. Okay, so now let me just highlight the ones you should really look at. Okay, so now I want you to focus on two things over here. Number one, look at this particular declaration over here, add RS. Oh, sorry, not add RS, add S. First of all, look at this particular one over here. And then second of all, I want you to look at this particular argument over here. Call by value simply says, whenever you try to make a method call or feature call, you only copy the value of the argument you're passing. However, it depends on what the type is for the arguments. If the type is simply primitive, like an integer, double, or Boolean, you copy the value. However, if it's reference type, you only copy just the value for the address. You don't copy the whole objects, right? For those of you who forget about call by value, maybe you got to review a little bit. Okay, but let me say this. It's more like a pointer. How about this? Basically, what we're doing is this. We got RS over here, which is pointing to a resident students objects over here. Agree? And now, when we are trying to give this as an argument for this particular feature, however, for this particular feature over here, we have another variable called S, right? And to judge to see whether things should compile or not, we use S rather than RS, right? So now, call by value is as if we do the following. We say S over here is simply assigned to RS. So that means as if we're trying to create an alias for RS over here. Okay, well, it's more like a combination of what you learned in 2030 and what we're learning now. Okay, I really want to make sure you're okay with it. We do see lots of things like this later, okay? Please make sure you're comfortable. Now, first of all, are you comfortable by saying, whenever I'm trying to make a feature call like this, where RS is the arguments, and S over here is actually, they call the formal parameter, which we declare over here, right? It's as if we are doing this assignment. Now, since we talk about in assignments, everything we learned before can still apply, right? So now, back to my original question over here, will this particular feature call compile or not? It will, right? Very good. Because we know RS, the static type is simply resident students. And what about S? It was declared to be a students. So this is a descendant class of that. So this will compile. Okay, notice that even though we declare statically, each element of the array is a students. However, when we try to store something into it, we can store any object whose static type is a descendant class of that. That's how we make polymorphism. So this is the most interesting bit about OOP. Okay, and we'll see a little bit further to see what the advantage is. Okay, okay, guys, to test your understanding, I got tons of exercise to go over with you. Okay, okay. For this one, I just mentioned that call by value. Okay, you can review it. So now, so that's exactly what we just said. Okay. So now I want you to tell me yes or no. Yes for compile, no for not compile. It's a warm-up. How about this one here? I heard yes, okay, because S1, the static type is simply students, and for add S, it's simply just student, right? So student is a descending class of itself. Okay. How about this? S2, oh, that's easy, okay. S3, okay, basically repetition. How about this? Yes, that's something we just talked about, right? RS over here, static type is simply resident students, which is a descendant class of this parameter type of add S, which is students. Okay, good. Pretty good. How about this here? Right, because simply NRS, the static type is non-resident student, which is another descendant class, right? So you can put any object whose static type is a descendant class of the element type of the collection. That's something we'll apply many times. Okay, can I bother you with one more? Who said yes? No? Okay, good. Why not? Aha. So, yeah, okay, let's see very quickly. Okay, for this particular one, okay, you can see, first of all, you can see S1 over here. The static type is simply just students. And then the static type, you know what? To really make sure you understand this. Okay, that's exactly here. Okay, that's exactly this line over here. Okay, S1 over here, the static type is declared to be a students. On the other hand, if you look at, for this particular feature over here, add RS is exactly over here. The parameter is simply resident students, right? The parameter is the resident students. So it's as if we try to do RS is assigned to S1. RS is over here, right? Which is resident students. Assigned to S1 over here, which is students. You cannot assign student to resident students because student is not a descendant class of resident students. That's exactly how you judge. Yeah.
So, features for adding different students when they now.
Very good. So basically, the reason that I had add S, add RS, and add NRS is because to show you different variants you might want to do. However, which one should you keep for your final version? Add S. Only one feature over there, so that you can add as many different types of students into it as long as they are descendant classes of students. Okay? Yes, eventually, yes, you don't actually need add RS and add NRS. If you have them, that means you don't understand the problem good enough. Okay? Good. All right. So hopefully you're comfortable with it. Okay, now type checking. You can see we've seen example. Let's formulate that very quickly. So now over here, now you can see that over here, if I simply get x dot f y, x is an object variable, f is a feature name, y is just another variable. Whenever a compiler sees this line in Eclipse, in Alpha Studio, in Visual Studio, doesn't matter. They use the same rule. Okay? What would be the rule for this whole line to be compilable? I'll give you one to start with. Let's just assume. Let's say for x over here, we can simply say the static type is simply capital X. Let's say, okay? Let's say the static type for y is simply capital Y. Okay? Rule number one. We want to make sure feature f is declared in class X. You want to make sure at least there's such a feature, right? That's number one. Okay, now what else? And yeah, that's exactly what I said in number one. Yeah, good. What about another one? Let's say the feature is really declared, so we can call that. But now, how can you be sure passing Y in this case is allowed? Exactly. Very good. Yes, correct. The number of parameters should really match. Of course, usually they will actually go through a list. You guys are lucky. That's something I'm thinking about to be the project for the fall 2019 to implement a compiler like this. Well, you want to retake it with me, that's fine. In the fall. If not, that's fine. Yeah. Anyway, that's okay. Let me write it down. All right. Number two over here, basically very quickly, the static type of y is a descendant of the formal parameter type of f. Okay, something we just talked about. Okay, why don't we have a very quick check over here? Well, that's something we have done already, right? Can we have a look at just two lines? How about that? Number one, should it compile? Are you sure? Don't pre-assume anything. Sometimes that what I give to you may just be garbage. Are you sure? Are you sure it's going to compile? Okay, let's try. Can you actually call add rs in S1? No, right? Right, S1 is of static type students. Student class does not have add rs. You know, I got a feeling some of you might write something like this in lab test on Friday. Please, okay? Always be careful what you're writing. Yeah, you know, in some ways it's tedious, I agree. And well, you know, you should be grateful somehow compiler does this check for you. You don't have to check it manually. Think about if there's no compiler. You got to write such things by yourself and then hoping that everything's okay. No crash, right? But it's not. You're okay. Okay, you're basically saying if we add a feature called add rs to students, yes, that might work. But that's not something you want to do. You want to see exactly why it is wrong now. We don't talk about fix over here. Okay? Also, it doesn't make sense to say have an add rs in the student class, right? Do you add itself to the, right? Yeah, that's fine. Okay, good. Okay, let's see one more. Okay, shall we? Just see one more. Okay, what about this guy over here? Okay, so let's try. Apply exactly this rule over here. SMS, static type is SMS, which defines IRS. Okay, that part is fine. Number one is okay. And now, S3, the static type is simply NRS. For at RS, the formal parameter type is RS. Okay, so now is NRS. So what we're doing over here really is S is assigned to S3, the S over here. That's what we are really doing over here. Should that be the case? So is NRS over here descendants of RS? Is it? No. Okay. It doesn't compile. Okay, that's how you decide. Are we okay with this? You might, somehow you might find it challenging because we try to formulate precisely what's going on. That's why it will be a little bit tedious. But I think since you're a third year, you deserve to know the complete details. Okay. But if you're only in 2030, maybe I wouldn't bother you with that. Okay. But I think you should really try to go beyond the examples. That's what I hope. Okay. Good. That one's good. Okay. You know what? How about just do one more? Okay. How about this one here? I tell you what. Somehow you learn about feature arguments, type checking. You learn about Caste, right? Let's say the Caste itself is valid. Let's say, and also it can be Caste without any problem. How do I know if this particular line is going to compile? Exactly. The point really is, what's the static type for temp over here? Whatever we cast that into, right? Basically, the static type over here is C. We want to make sure C is a descendant of whatever the formal parameter type is for F. Okay, then we're done. Shall we do 1, 2 exercises quickly? How about this one here? Oh, actually, this one has a return value, which we'll get into, and then we'll come back here. Okay? Are you guys comfortable with this? Okay, good. Let's talk about return value quickly. Okay, that's about feature arguments, which we went through, and now let's go to return values. Oh, before I go to return values, basically we talk about polymorphic collection, so that's a very important decision you have to make. Basically, every time if you want to declare the type of a collection, you want to choose maybe the most accommodating type for your particular application. For example, if you got students, resident students, and non-resident students, you got 3 choices. Maybe if you want to choose students. In that case, you can store as many descending classes over there as you like, right? Okay. So now let's see the final code over here. We got student management system over here, and then we got, okay, you know what? Let me just go over the code from iPad. That might be a little bit easier. I can visualize something quickly for you. What we want to see over here, first of all, let's see, we got student management system here. So we got students, which is simply a linked list of students. Okay. So now this is the static type. Okay. Dynamically, we may store either resident students or non-resident students, right? Or student itself. So let's say we only got one feature. So back to what you asked. So that should be the only version we keep, right? So now we keep the most accommodating version. Okay. And then we simply do extend. So far, so good. And now we'll get to this feature eventually. This is really the gold of having polymorphism, which we'll get into. Okay, we'll get into that. When you review the slides, I want you to compare this particular version of the student management system with the version where there's no inheritance. In which case, we had to go through 2 separate arrays. One for resident students, the other one for non-resident students. But now in this version, only one version is necessary. And what's more, it doesn't matter how many descendants you have for the students. If you got 100, you still have a single loop. Okay? So now, let's have a quick look at a very quick test. And this is something I'm going to draw very quickly to give you some intuition, but we're going to redraw the same diagram for many times for the design patterns. Okay? So now, let's say we got RS, we got NRS, we got some course, we have some student management system, right? Let's draw very quickly. First of all, we have a resident students over here, which is pointing to some resident students, okay? And then we simply have Jin, and then we set a premium rate to be 1.5, okay? Just as a sketch. We have another one of a different dynamic type. You can see NRS, we simply say creates Jeremy and 0.5, right? So that means we got NRS, which is pointing to different types of objects over here. NRS is going to be Jeremy, and then also 0.5 is the discount rate. Okay, so far so good. So now over here, we are trying to create a student management system objects. Let me put it here. Student management system objects is going to point to SMS, and the critical feature we have to draw will be the linked list of student, right? So now let me just put SS for students. It's just going to be a linked list. Initially just empty, initially. Okay, I'll just put something like this, initially empty. So now let's see what's going to happen in the following two lines. Line number 1, is it going to compile quickly? Right? Good. I assume you know why, okay? What that's going to do is actually going to add the first elements in the linked list and then make it point to this particular resident students. Okay? Let's see a second line. Let's say pink. Similarly, this line should also compile, agree? Calling the same add as feature, but that should also compile. So now what's going to happen is we're simply just going to create another cell for the linked list, and then it's just going to point to NRS. So this is exactly the so-called polymorphic collection, because the static type for the students is simply just students. However, the dynamic type at the runtime can be resident students or it can be non-resident students, polymorphic. When we talk about the 3 different design patterns later, you see this always. Okay? So please make sure you understand this part here. Okay, so now let's say we also create some course over here. That's going to be an interesting bit. Let's say we create a single course, let's say for 3311. Let me just put it here. Let's say there is a course over here. Okay, course. So which is 3311, let's say 500 for the fee, for example. Okay, there's a course objects. So now we have to understand the next 2 lines very well. Let's say the first one. How about orange? How is this going to execute? Absolutely. Let's try. Okay. So it's going to compile. Okay. So what we do is we're going to go to the register all, which is over here. Yeah, exactly. So C is actually declares course. Course is the descendants of itself. So that's not a problem. Very good. Very good. I like that. So now we can do, oh, by the way, you should know how to implement iterated pattern for Friday, right? The fact that students is a linked list, collection is automatically iterable. Okay? So now we simply go across the students objects over here. How many iterations do we have in this case? Well, 2 iterations, right? The first iteration, we're going to look at this particular objects. The second iteration, we'll look at this particular object, right? 2 iterations, okay? So now, let's think about this. As the item over here, I have 2 questions for you, okay? 2 questions, very important questions. So now, let me just draw a very quick table over here. When you talk about iteration number, we know that it's going to be 2 iterations overall because we got 2 objects over here, so 2 iterations. Okay? Now, it's very important to see for this particular S.item over here, I want you to tell me, number 1, what is the static type for that particular expression? And then, between the 2 iterations. And then, followed by that, I want to know what's the dynamic type between the 2 iterations. So you got 4 things to tell me. Or you meant it the other way? Okay, how about static type first? So now, what is the static type for the very first iteration? The very first iteration, we're going to look at this particular object over here, or to be more precise, we can look at this particular cell. What's the static type? Students or RS? Aha. Exactly. Static type, remember, never changes. Once you declare that, you don't change it, okay? So this should be students because you declare that to be students. Similarly, in the second iteration, even though you're looking at this particular slot, even though it's pointing to a non-resident student object, doesn't matter. The static type is as originally declared. Okay, it's still going to be students. Okay, that's static type. What about dynamic type? RS and NRS, agree? Okay, so for the first iteration, it's simply just going to be talking about this object here. It's going to be RS, and for the second iteration, it's going to be NRS. Okay, this table is also very important. Okay, it's polymorphic. Remember, polymorphic in the sense that static type for the elements is uniform, it's the same. The dynamic type is simply subclasses of the or descending classes. Okay, so now let's go a little bit further. Once we understand very well s.item, right? So what about calling register over here? First of all, calling register here, should it compile? It compiles because of what? Because of static type, yes. Okay, the register over here should compile because the static type of students declares that. Okay, not because of the dynamic type. When you talk about compilation, you don't talk about dynamic type. Okay. Okay, let's go a little bit further. So now, in this particular case, that's why declaring the linked list of student here is so useful, because it's guaranteed the register is supported at the student level. If you refer back to the code, right?
So I have a question.
Yes.
Compiling and running.
Yes.
So it will compile, but it won't run if register is not featuring RS or NRS.
Okay, let's, I see what you mean. Let me change your question a little bit. I do know what you're confused about, okay? Let me bring back the inheritance hierarchy over here, right? Let's say we got students over here, and we have over here resident students, and we have non-resident students, okay? So now we know that in a student we got name, we got courses, and also we got register, and also tuition. So these are the 4 features, right? And let me just mention one feature that's new. So we got discount rate over here, that's new, and also we got tuition that's redefined. Over here we got premium rates, and also we got tuition that's redefined. Okay? Okay, just to remind you very quickly, otherwise you might get a little bit lost. Okay, so now, the reason that this particular register is compiling is because the static type is simply students, which does declare register. It's about compilation, okay? But which version is going to be called? Dynamic type. However, in this particular case, because RS and NRS, they simply inherit this version, so just that version. Okay, we're going to see a different story in just a moment. Okay, now, let me go back to your question, which is very valuable for the rest of the class. What if I said the following? Let me change this line just a little bit, okay? If I say s.item over here dot set premium rates 1.2, which means I want to change the premium rates for every element in the array. Is this going to compile? Why? Compile. Are you sure? Wow, you know what? I almost want to have a specialized exam for section N. I will ask you a question only about this. I already drew the hierarchy to you, right? According to the hierarchy there. No, right? Okay. Actually, okay, good. So now you can see that this is not going to compile because the static type for this particular expression, as we know, is students. Students does not define set premium rates. However, let me go a little bit deeper, okay? Of course, we can trick the compiler by doing a cast, because I'm so sure the first one I encounter over here is a resident students. If I simply say the following, okay, let me put it here. I would say check resident students, and then I can say s.item as some resident students, then I'm just doing a cast, right? And then I can say rs dot set premium rates. and then end. Does it compile? It will compile because, okay, you can see over here, you can see we are trying to cast that into resident students. So now that means RS has a static type RS, right? It's a downward casting. So set premium should be available. Yeah, no, it only have a compilation. When it's a running, that means talk about runtime. It's a different issue. I want to show you how easy for you to go wrong. So that's why you really want to be disciplined when you program, okay? So now this compiles, as we just explained. Now, which iteration might go wrong? We got two iterations over here, right? The first iteration, we look at the resident students over here. Would that be okay? Basically, you're casting into a resident student, right? What about second iteration? That's not good. This actually goes back to our conclusion last time. When you try to do cast, make sure you don't cast that into something that's neither, that's not an ancestor of the dynamic type. Because dynamic type over here is simply NRS. How can you cast that into RS? Okay, so now another lesson for you, okay? You want to make sure you do the minimum number of casts in your code or your design. When you have too many casts in your design, there's some problem there. So in this case, when you have to do a cast like this, you're being too specific about what it is. Okay? Because in general, the array can store any student objects. You don't want to be so specific about what they are. Okay? Guys, are we okay? Okay, I'm just trying to go deep into the issue so you really see. By the way, whatever we talk about now, that's transferable to C# or Java, right? Everything is transferable. It's not specific to iPhone. Okay, so can we just do one more over here? Okay, we know there's polymorphic over here. Can we just do one more line? Specifically, I want you to compare these two expressions. Number one, and also, let me just use this color here, and number two, blue and green. I tell you what the interesting bit here really is. If only by looking at the code, they are basically identical, except that the indices you're using here. The left-hand side, you use 1. The right-hand side, you use 2. Okay? Now, should the blue compile? Because the static type for SS at position 1 is simply students. Similarly, the static type for SS at position 2 is also students. So both should compile. That's polymorphism. Okay? Now, at the runtime, why do they return different values? You can see one of them is returning 750. And whereas the other one is 250, right? Why? Aren't we calling the same tuition feature? No? I agree. Can you be a little bit more specific? Absolutely. The first, thank you. I agree. The first one over here, when you call tuition, it depends on the dynamic type over here, which is resident students, which will apply the premium rates 1.5. On the other hand, when you actually do this position 2 over here, at the runtime, we're referring to this particular object which got discount rate 0.5. That's why you get different values. You can see only a few lines of code here. We've got many things to really get clarified. Okay? Yeah. Guys, any question for me before I move on? Sure. You mean I talk about this line here? And you talk about here? Sorry. You mean here? Okay. What about it? Yes, you may want to do a little bit of a check to see if, for example, let me use a bit Java term here to make you comfortable. You might say if the current element I'm looking at instance of resident students and then I do a cast. Otherwise, I don't do a cast. You might do something like that, but that will make your code a little bit too ugly. You don't really want to do too many instances of and too many typecast. It's just going to make your code too complicated. You really want to exploit polymorphism and dynamic bind in this sense. You want to avoid Caste. Now think a little bit more, and then maybe talk to me during my office hour. Okay. Okay, are we good? Good. So now can I just do one more type checking rule with you? Oh, actually, that's about, we haven't get to the return value yet, so that's the return value. By the way, this is the most important illustration for this whole lecture. Polymorphic collection, we'll see that over and over, okay, before the end of the semester, polymorphic, okay? So now let's talk about our return value. Return value is actually, in some way, is easier to understand compared with Java. Why? Let me explain to you. Syntactically speaking, in Java, how do you return a value? You say return. In IFO, you say result. It's easy to understand in IFO, slightly. It's easy for me to say. Over here, let's say we still got our student management system over here, okay? And then we got SS, the same as before, the same setup for add S. This is a new feature we have, get students. We want to get the student objects from this particular position in the array, okay? So now you can see that the static type for the return value is simply just students. So that means whenever you talk about the result, the static type is simply just students. So we have a variable to talk about over here. Are we okay with this? Okay, so now, given that, should this particular assignment be valid? Basically, whenever I want to get a particular student at a particular position, I just return that from the array. But now my question is, if you only look at this line over here, should it compile? Should it? Okay, why? What about right-hand side? Right-hand side, what's the static type? Well, as we learned, students. The left-hand side, it should be student as well. How do we tell? You look at the declaration for the return type over here. That's the new information you need to know. Okay, so that compiles. Okay, student is a descendant class of itself. Good. So now let's have a look at over here. Basically, when you go over the code, this is what you will see. Okay, we are trying to create basically NRS, SMS, etc. So we're basically creating the same polymorphic array as I just illustrated in the previous page. Okay, so now I want to just do very quickly. I want you to look at these two lines specifically. This one and this one over here. And the way, you know what? The way we visualize it is just the same. So basically, we have a student management system, and we got a linked list of students. The first one is pointing to a resident students, and the second element is pointing to a non-resident students. Okay, the same layout as before. Now, I have another table for you to fill in. Okay, over here. Okay, basically, we talk about static type and also dynamic type. Okay, static type over here and also dynamic type. So this is how we use it. Okay, number one, what is the static type for get students at position 1? In the student, right? How do you tell? Just go to where the student is declared over here. Okay. What about the static type for this? Also student, right? It doesn't matter what you're referring to here. It doesn't matter. Okay. It's just referring to the declaration over here. Also students. So now, what comes important over here is at the runtime. What's going to be the dynamic type when you say get students at position 1? All right, exactly 1 here. That means you're going to return this particular object over here, right? Dynamic type is going to be RS, and the 2 over here is going to return this, which is NRS. Okay. Okay, return value is easy. Okay, there's another question for you to think about. Basically, the result over here is statically declared to be of type students. So now, when you want to say result is assigned to, basically in Java, you can return some objects. How many kinds of objects can you actually return at the runtime? That's the question. Yeah, okay, let me rephrase my question a little bit. we know that statically, this feature get students can return an object of static type students, right? What about at the runtime? What kind of object can you get from calling this feature? All the descending classes of student included itself. Very good. Okay, it's a very quick check. Even everything is related to each other. Okay. All right. So now, how about we just do one? Okay. How about two? How about two? Okay. So now, if you want to do, okay, this one kind of combine things together, right? Yes. Yeah. Mm-hmm. You can use precursor. Is that correct? Correct. I see what you mean. Basically, what you're asking is something like this. Let me just add a new page over here. So let's say we have a class. The same applies to Java as well. Okay, let me just say idle syntax, which might be useful for later. So let's say we got A here, method A, B here, and C here. So let's say method A is somehow redefined, and method A is redefined again. So we got 3 different versions of method A, let's say, okay? So now let's say if I'm in the context of class C, if I say precursor, let's say in the MA, okay? Okay, let me just make it a little bit more better. Okay, let's say in the definition for MA, I can say precursor. Okay, when I say precursor over here, basically I'm referring to the immediate above version. You might be thinking there might be some syntax like this to say precursor 2, which means I can go 2 levels up, right? No, there's no such thing, right? You don't have super 2 also in Java, right? So there's no such thing, okay? Just remember, you can only refer to the previous one. Basically, you can only refer to the closest ancestor version. Closest, okay? Good, and also if you say over here, do and end, and also when you say precursor over here, oh, sorry, I shouldn't really confuse it, there's no such syntax, okay? So if you say precursor over here, now, are we referring to this or that? A here, right? Okay, because it always goes up. You know, don't be. Some student actually said he was confused. Should I go up or go down? Well, either, right? Go up, right? Okay. Precursor here is referring to MA over here. Okay, just about the use of precursor. Yeah, it's worth noting. Yeah. Yes. Can you inherit from more than one classes? The answer is yes. It's something called multiple inheritance, which we'll cover later. Good question. Basically, what you have to do, you have to do a little bit of renaming of your features, but we'll get there.
And I don't remember Java having precursor.
Java got super.
Oh.
Super, yeah, super. Yeah, super is like a precursor. Yeah, good. Okay, but you know, conceptually they mean the same thing, right? Because you just refer to your ancestor, right? Okay, that's good. Guys, can we just do this one very, very quickly? Okay, good. So now, what would be the type checking rule for this? Okay, I tell you what, let's make it easy. Let's say this feature call here, we know how to type check it. Let's not bother, okay? Let's say already compiled just for this part here. So now, how do I know if this particular assignment should compile? Yes. Not quite. You're getting somewhere, but I like the pattern. You want to say something is descendant of something. That's good. Not quite. Okay.
The return type function index is descendant.
Aha, exactly. Maybe that's what you meant. Yeah, maybe. Okay, I guess. Okay, good. Okay, basically, the return type of f in, let's say this is in the static type of x. Let's say in x is descendants of z. Okay, let's do 2 examples together. Should this compile? Same trick. Hopefully you see that, right? No, because good. You're awake. That's good. Okay. Okay. So this wouldn't compile. Okay, it's trivial. Okay. Yeah. Good. Okay. Let's see one. How about here? Be careful. This one will be quite a nice summarizing example. Okay, so let's be a little bit careful here, okay? So now we know that the static type for this one here is simply students. Because we see that from here, the declaration, right? And then the static type for S2 over here is simply RS. Student is not a descendant class of RS. So no, doesn't compile. Okay, very good. Okay, let's see what else. Okay, now what I want to, we still got about 15 minutes, which is good. Huh? The other two, how about I leave as exercise for you? What you can do is when I post the iPad notes, you can refer to them and try to do it by yourself. Okay, yeah. Okay, so now, you know what, thinking this way, my student told me that when they actually went for a programming interview, so normally they may not want you to program in the computer. They may want you to program on a whiteboard, right? The good thing is your code doesn't have to compile completely. But the downside is it cannot be too ridiculous, right? You can see that, well, for example, you know, I think there was one student asking me, well, I hope she survived through the interview. She was asking me, well, what happens if I say sms.get s over here, I say 2. Yeah? Is it going to compile? No, right? It should be quite obvious to you, right? Because you expect an integer by passing a string, right? If you write anything like this in your whiteboard interview, it doesn't matter if it's on a whiteboard computer. I think you're going to skip to the next company, I guess, right? Well, this one is easy. I'm just trying to say, in some way, if you can program in the whiteboard in a way that's you got very minimal number of mistakes, especially got inheritance, I think you impress your boss. I think so. I do think so. Yeah. Python, yes, because Python doesn't do too much type checking for you. It's called dynamic typing. But I think for Java, C# or Java, C# or IFO or many other languages, they do static typing. Yeah. Okay. Yeah. So I would say sometimes, if you want to practice for your future programming interview, try to practice on the paper. I think that will actually be quite a nice exercise to do. Yeah. I do have some interesting question for you when we talk about program verification. Okay. We'll get there. Okay. Towards the end. Okay. So now what I would like to do is to give you a little bit more design tips over here quickly, and then we finish the inheritance topic, and I can talk a little bit about generics. Okay. And you can definitely finish that next time, for sure. Okay, so everything has been talked about over here. Okay, let me give you a little bit more design principle over here. So now, basically, in general, if you declare an attribute A of type T, so for example, should T be a student? Should it be resident students? Or should it be a non-resident student? It's more like a design choice over here. Right? Basically, what you want to think about, okay, basically, let me just make it very precise to you. So this is really what you have to keep thinking to yourself when you do the projects. I got 3 choices here. Either I can say S students, S resident students, S non-resident students. Oh, sorry, I forgot. Sorry. Yeah. How about this? You know what? Let me make it even a little bit more common for you. Single variable is not that fun. Can I say array over here? Array. Array. So I got design number 1, design number 2, design number 3. By the way, there's no right or wrong. Which one you choose, it can definitely justify towards that particular direction. But you want to really know under what circumstance should you choose one but not the other. Okay? How about I give you a little bit hints over here. You want to justify whether you choose D1, D2, or D3 in the following sense. Once you commit to it, you want to minimize the number of castes or instance of checks in your code. Okay? So what will be the criterion for you?
So if I choose design 1.
Let's say you choose design 1, let's say. Yeah. So what would be the justification for that?
It's in the, I'm going to use RS and RS
Well, let me help you a little bit. If you choose design number 1, that means you're being very accommodating when you store objects into your collection, right? So that means you can store either students, you can store dynamically, you can store RS, you can store NRS. You can store these 3 kinds of things over here. However, when you say SS at a position I, what's the expectation over here? Only at the student level, right? So that means you shouldn't really, well, you should only expect to see, for example, tuition. You can do register. However, if you try to do premium rate, that's not good, right? If you actually choose this one, that means you realize that's the decision you want to commit to. If you find that if you declare this particular design decision here, but later on you find that you had to use so many castes to actually do cast into resident student and do the premium rate lookup, that means you should have chose this in the first place. Okay, that's kind of on the other hand, if you actually chose D2, what would be the justification for that? Yeah, actually D2 and D3, they're somehow symmetric, right? D2 is very restricting, very constraining, because now, what can you store dynamically to D2? Just RS, exactly, just RS, nothing else. Because none of the other 2 classes are the descendants of RS, right? So now, once you get it, the storage is very constraining, but now for the calling the feature, you got more expectation, right? So now SSI, over here, you can say register, you can say tuition, you can say premium rate, you can also say set premium rates, right? So these are just design trade-offs you want to make, okay? Guys, make sense? Good, very good. So now, again, there's no better or worse. It completely depends on what you need. But I would say typically, you may want to choose this one to make your design very flexible. If you have a good reason to use D2, by all means, do it. Okay? So always you want to justify, right? Okay, that's about the final slide. You can just go over them, pretty much the same. Okay? So now I want to talk to you a little bit about generics quickly. And then I will give you a challenging exercise to try together in the beginning of next Monday. Okay? But now let's do some very basics about generics quickly. Okay? The reason I want to talk about generics after inheritance is because the scenario where we are motivated to do generics is exactly about polymorphism and dynamic binding. Exactly that. Okay? And also Caste. Right? Remember when we first talked about generics in the very beginning of the course, I simply do that from a code reuse point of view, right? If you got a stack of strings, stack of person, just replace by some other, just G, right? That's a little bit too informal. Let's be a little bit formal here, okay? So now, as always, let's do a motivating example quickly. Let's say we have a class called book, okay? Like a birthday book. Okay. And we have names, which is an array of string. And we have records, which is an array of any. Any like objects in Java, right? So now, is this a very accommodating or constraining design for records? Accommodating. Because any class in IFO will be a subclass or descending class of any. Like in Java, any class will be a descending class of objects. If you have an array of objects in Java, that's very accommodating for storage. But return is the opposite. There's no such thing that will be very good for both sides. You're going to strike a balance over here, right? Absolutely. That's why this is a motivating example, right? Yeah, that's why. Okay. All right, let's see how bad it is. Okay, so now we got some make feature here to create an empty book. And then we also got, let's say, add. You want to add some name and record, right, into it. Okay, record is any. Which means you can add birthday, you can add maybe address, you can add maybe GPA, you can add anything. You can even add binary search tree, whatever you want to add, right? And get, wow, get is also interesting. Because you can store anything into it, you can also get anything. You know, in some way, if you try to say it in English, it's like you have done nothing, right? You can store anything, you can also return anything, right? That's why the design is not that good. But let's see why, okay? You really want to know the rationale, okay? So now, which line, now I'm going to describe some lines of code. Tell me which line is going to be a compiler error. Based on what you learned previously, you are absolutely prepared to answer. Line number 1, would that be okay? Oh, here, what? Line number 1, can you see? Line number 1, okay. Should it compile? Let's say date is a known class, date. Just like a date, right? With a year, with a year, with a month, with a day, let's say. Let's say it's a defined class in the library, let's say. We can assume that. Line number 1 is okay, right? Just declaring something, right? Okay? Good. Should be okay. Yeah, of course. Line number 2, also fine, right? Okay, declaring a book, and also declaring whether a particular day is Wednesday or not, right? Whether if somebody was born on a Wednesday, for example. How about this? What you have to check now is whether this dynamic type over here, book, is a descending class of the static type. It is. Okay, good. Now, number 4. Yeah, well, it's just assign a string to a string, right? Pretty good. This. That's fine, right? Specifically, you can see that the phone number over here, the static type is simply string. But because the phone parameter is simply any. Okay, that's good. And now let's say we create a birthday over here, 1975, 410, doesn't matter. Okay, that's okay. How about that? You can see how arbitrary this book can be. I store birthday, I store phone book, right? Phone number. Okay, so now here comes the last line, which presumably got compilation error, right? Basically, this is what I want to do. I say I pretty much know. For Yuna, I put in line number 7. It comes later. It's a second record. I simply want to get the associated record for Yuna, which is the birthday. For that particular birthday object, I want to know if that date represents a Wednesday. Let's say it's get day of week is actually supported in the date class. Let's say it's going to return either 0 for Sunday, 1 for let me see. Sorry, 1 for Sunday and 2 for Monday, and etc. Right? It's really important to get this right. Yep. Whenever I talk about compilation, always look at static type. Oh. Okay, you know what? Okay, let me just switch to iPad over here. Basically, we're focusing on this particular line over here. Okay, so now, let me go a little bit step by step, okay? If you actually look at this particular assignment over here, is that okay? Because somehow you're trying to do something like a get day of week itself is actually going to give you some, and you want to say if that's actually equal to 4, that's going to give you a Boolean. So that part is fine. However, if you look at this part specifically, do we have any issue here? Just that part. Okay. The part at box, over there. What's the issue there? It's really important. Since we talk about compilation, right? Only worry about the static type. The static type can either be variable declaration, can be parameter declaration, can be return type declaration. Right? Go ahead.
So because n is very, very hot, it's not
So you're talking about basically b.get statically is going to return any. And now get day of week. So you can think about any is over here, and then the date must be a descending class of that, right? So the get day of week is simply not supported, even though we are so sure the associated data for Yuna should be a birthday. Now, how can we be, since we are programmer, we are more flexible. How can we make the compiler happy? Caste. Okay? Let's make compiler happy then. Okay? And then we'll take consequence later. Okay? Well, are we okay with the why this is the issue? We're okay, right? Oh no, the reason is, okay, if, let me highlight it quickly. If you look at b.get unit over here, statically speaking, it's going to return any. Okay, and then you can see that over here, when you try to call this particular feature get day of week, it's simply not declared in the any class. That's why it's problematic. Okay? What? Huh? Say it again. Yeah, you can definitely do it. Yeah, you're talking about line number 3, yes. Because if the dynamic type and static type are the same, you can ignore that part. You can omit that part. That's fine, yeah.